All right. So number 7 was the first one that you guys had. Whoa. Let's get back to there. Was the first one we had a question on. What's the first thing you're supposed to do when you factor? Look for a GCF. What's the GCF? 2. So factor out the 2. 2x squared divided by 2 is 1x squared. Negative 18 divided by 2 is negative 9. What's number 2 on our list, our steps for factoring? It's got 2 terms, both perfect squares, and minus between them. It's called a difference of squares. Okay? So you keep the 2. And when you do a difference of squares, you make 2 sets of parentheses. And you take square roots. The square root of x squared is x. The square root of 9 is 3. So front and back, and then one's always addition and one's always subtraction when you factor a difference of squares. That's how you do it. Take out the GCF first. Number 8. Lucas, you find it?
X plus 4x plus 4.
No. Cool.
2x minus 1, 3x plus 4.
Yes, let's look at that one. We got 6x squared plus 5x plus or minus 4. So we look for a GCF. There isn't one. It's got 3 terms. So I'm going to jump all the way down to number 4 on our steps for factoring, looking for that trinomial square or a perfect square trinomial. Are these both positive perfect squares on the ends? No. 6 isn't a perfect square, and the 4 is not positive. All right? You got to be positive perfect squares. So it's number 5, a regular trinomial. What's my a value? 6. So when a value is not 1, we have to multiply the a times the c. You get negative 24. Now we're looking for factors. What times what? Gives me negative 4, but adds to give me positive 5, which would be 8 and a negative 3. If I multiply 8 times negative 3, I get negative 24. And if I add 8 and negative 3, I get positive 5. All right, so I'm going to rewrite this problem. The first term doesn't change. The middle term, the 5x, changes to 8x minus 3x. Positive 8x minus 3x, and then the minus 4 doesn't change. So the a and the c part doesn't change. The b part, you split up into those 2 numbers, Abby.
Does it have to be in order? Like
No, you could have negative 3x plus 8x. Doesn't matter. Okay, now we group it. We turned it into number 6 on our list. So grouping problem, got 4 terms. So I'm going to group the first 2 and the back 2. Since the third term has a minus in front, I keep it in my group and I just put a plus sign between my 2 groups. Now, I take out the GCF from each group. What goes into 6x squared and 8x? 2x. What goes into negative 3x and negative 4? Just negative 1. Whenever this third term, this 3 has a minus or whatever it is, has a minus there, pull out the negative. If there's nothing common like this one, you put the number 1 because 1's common to everything. Now, you divide 6x squared by the GCF 2x, and you get 3x. Negative 8x divided by 2x. I'm sorry, positive 8x divided by 2x is positive 4. Do the same thing. Negative 3x divided by negative 1 is positive 3x. Negative 4 divided by negative 1 is positive 4. What do you notice about the 2 red parentheses? They're the same. That's what's supposed to happen. That's one of my factors for this problem. My other factor is the blue numbers, the GCFs you pulled out. The 2x minus 1 is the other factor. if I FOIL these two together, I'll get what I started with. So that's how I factor one of those trinomials that has a number other than 1 for A. Questions? Okay. Number 9, I'm going to pick up the pace. 2x minus 1 and x minus 2. If you have a question, just let me know. We'll go over it. Number 10, 2x squared minus 1, 4x minus 3. Number 11, 5x plus 1, 5x minus 1. That's a difference of squares. Do the square roots. 1's plus, 1's minus. Number 12, let's go over that one. That's one of those special trinomial squares. And again, if you don't realize it, you can do it as a regular trinomial. You'll still get the same answer. But this one, there's no GCF. So I drop down to number 4 because number 2 and number 3 on our list have only 2 terms, remember? All right. So is the first and the third term both positive and a perfect square? Yeah. So I do a thing I call the 1, 2, 3 test. To get number 1 answer, you take the square root of this first term. The square root of x squared is x. To get number 2 answer, you take the square root of the third term, the c. The square root of 36 is 6. To get number 3, you just multiply the 1 and 2 answer together. X times 6 is 6x. If number 3's answer is half of the b value, is 6x half of 12x? Yes. Then it's one of those special trinomials, one of those trinomial squares, or a perfect square trinomial. And the way you factor those is you can make one set of parentheses. Okay? And then you take what you got for answer number 1 in the front. The answer for number 2 goes in the back. Look at the 12, the b, and its sign. Since it's a negative 12, you put a minus, and then you can square it. There's 2 of them. If you did it as a regular trinomial, what times what is positive 36, but added is negative 12? Negative 6 times negative 6, right? This means there's just going to be 2 of them. So if you wrote x minus 6 times x minus 6, you're right. You did it the regular trinomial way. You still get the right answer. But this may be a little quicker. When we do something called completing the square here pretty soon, we'll be turning our problems into one of these types of trinomials, one of those perfect square trinomials. Number 13 is x plus 1 and 3x minus 1. Number 14 is x minus 1 and 5x plus 2. Any questions so far? Others? All right, let's look at number 15. X cubed plus 2x squared plus x. Is there a greatest common factor? Ryan? X. Yes, thank you. So pull that x out first. X cubed divided by x is x squared. 2x squared divided by x is 2x. X divided by x is 1. There was 3 terms we started with. So there should be 3 terms in our parentheses when you take out the GCF. When we did number 7, we took out the GCF and we had 2 terms to start. We have 2 terms in our parentheses. The same amount. Okay? So, this is one of those regular trinomials then. A is 1, so it's real easy to get x squared, x times x. And there's only one set of factors for 1. What are they? What times what is 1? 1 and 1, right? And what is 1 plus 1? 2. So, actually, it could be the 1, 2, 3 test would work there, right? X squared is a perfect square. 1's a perfect square. If I did the 1, 2, 3 test, it would work out. So you could have written it like this if you wanted. Number 16, take the 2 out for the GCF. And then you're going to get 2, and then the quantity x minus 6 and the quantity x minus 8. Again, it doesn't have to be in that order. Number 17, you got to go 4 times 3, get 12, and use negative 12 and negative 1 to get positive 12, and add it to get negative 13. Rewrite it, group it, and you get x minus 3 and 4x minus 1. Number 18 is already a grouping problem. You get 2x plus 1 and 3x squared plus 4. Number 19 is 4x minus 3 and 2x minus 1. Any questions up to 19? Some of you are zoned out. You're not learning. You're going to get an opportunity to get bonus on Thursday. You're going to have about 10 of these, or 11, I don't know. Okay, maybe 12. For every 4 you get right, you get 1 summative bonus point. All right? Easy bonus on Thursday. No homework. Okay? No homework tonight either. Just pay attention, okay? Don't zone out. The last one is 49x squared, a perfect square, plus 16, another perfect square. Is that a difference of squares? No. Difference means what? Subtract. What's in there? Addition. So this one is not factorable because it's plus there. If it's minus, then it's 7x plus 4, 7x minus 4. That's what some of you put. If it was a minus between them, you'd have been right. Since it's a plus, you can't do it. Okay? So, be able to factor if you want to get some bonus points on Thursday. Once we start chapter 3 next week, you're going to have to be able to factor to do some solving of quadratics that we're going to be doing. Okay? Today we're simplifying radicals. All right? Square roots. Okay, so the way you simplify radicals, you don't just put in your calculator and see that it's 3 point something. Okay, we want it in simplest radical form. So we do what we call a factor tree. You can start with 4 and 3 or 2 and 6. Doesn't matter. Okay, now I like to stop there and circle the 4 because 4 is a perfect square. Some kids will do this. Make this 2 and 2. And look for and circle those because there's a pair of 2's. So when you're looking for square roots, you're looking for pairs. For every pair, you can take that number out. I have a pair of 2's, so I can take a 2 out. All right? Or I circle perfect squares, and I know the square root of 4 is what? 2. So that's how I pull the 2 out. So I stop right there. Some kids go all the way down. It's your choice. You can go all the way down and look for pairs of the same number. And for every pair, you take that number out. Now, whatever you take out, you multiply out front. Whatever's left, you multiply underneath the radical. Okay? What's left is the 3. We just simplified that. We'd say 2 radical 3. The square root of 12, or radical 12, is 2 times the square root of 3, or 2 radical 3. Okay? That's simplest radical form. Right? So, what do you want to multiply to get 80? What 2 numbers? Your choice.
I think an 8 and 10.
Okay. 8 and 10. Neither one of those is a perfect square, so I'm not going to circle anything. Keep going.
4 and 2 for 8. And 5 and 2 for 10.
Good. Now, here's what I would do. I see these 2. I circle them. I see this, I circle it because it's a what again? Perfect square. Right, John? What's the square root of 4, John?
2.
Very good. So I'm going to take that 2 out for that 4. If I got a pair of 2s, what do I pull out? A 2. And you multiply them. Whatever comes out, you multiply. What's left underneath? The 5. So this answer is 4 times the square root of 5. Okay? Now, Cole went 8 times 10. Here's how I would have done it. Just to show you. I know 16 times 5 is 80. And I know the square root of 16 is what? 4. So I would have stopped there. My 4 would come out and my 5's left. Again, it doesn't matter how you start your factor tree. I always like to try to think about perfect squares that go in there, right, James? Stay with me. What would you use, James, for that 500?
215 too.
Okay. Again, doesn't matter. Some of you might have thought about something different. Keep going.
145.
Okay. I'll put a 2 here. 25.
25 and 5.
Okay. I would stop there because we all know 25 is what type of number? Perfect square, right? So I'd circle it. And then I'd circle these because there's 2 of them. So what can I pull out at Barrios?
2 and 45.
Well, not the 25, the square root of 25. So a 2 and a 5. Yeah. So we pull out a 2 and a 5. And then what's left? You guys see the 5's left? So this would be 10 times the square root of 5. Now, again, James didn't do anything wrong. I would have started out, just to show you, to save you some time, I would have done 100 times 5. Because I know the square root of 100 is what? And you guys know the square root of 100 is 10. So there's the 10 there. And then the 5's left over. So again, it doesn't matter how you do your factor tree, you'll get the same answer. We'll all get the same answer. Is that making sense? Man.
What about the 3?
Oh, I get ahead of myself, and I forgot about the 3. Thank you. What do I do with that 3 and the 2 and the 5? You got to multiply them. I forgot. I was getting ahead of myself here. So the answer is actually 30 times the square root of 5. Thank you, man. Everyone understand that? So if there's a number already out front, like this one, whatever we pull out, we multiply it times that, the 3, the 2, and the 5. We multiply them all together. Okay? Any questions? Sam, what would you do for 50? Okay. I'd stop there because I know that, and you guys know that's a perfect square. So Eddie Fisher, what's the answer?
2 and -4 or 4. I don't know.
Well, the 2 doesn't come out. The what comes out?
So 5.
Well, the square root of
5.
5 times -4.
Yeah.
Okay. So the one that's the perfect square, that's the number comes out. That's one mistake sometimes we make. We keep the perfect square underneath and we take the other number out. No, it's the perfect square of what you have 2 of. We have 2 5s there. Okay. So that's what you take out. So far, so good? Any questions? Okay. Sometimes we get fractions. Okay. Think of these. First of all, can you reduce 3/5? Is there a number that goes into both of them? That's the first thing you should try to do. If you can reduce the fraction right away, go ahead and do it. Make sure they're both under the radical sign. If not, then think about the problem like this. In algebra, you're not allowed to have a radical in the denominator, a square root symbol in the denominator. Okay, because a radical, a square root of 5, is called an irrational number. Okay, so we have to do what we call rationalize the denominator. Okay, so the way we do that, the way we get rid of that radical sign in the denominator, is multiply the top and the bottom by that denominator. What is a number divided by itself always equal? 1. So basically I'm multiplying by 1. When you multiply a number by 1, what do you get? The same thing, right? So basically we're just multiplying by 1. It's just going to look different, okay? This way we're getting rid of the radical in the denominator, okay? So we just go, since they're both under the radical sign, I can multiply them. What's 3 times 5? 15. What's 5 times 5? 25. But what is the square root of 25? 5, right? So here's our answer. So the square root of 3/5 in simplest radical form, the correct form, is the square root of 15 over 5. You cannot reduce that 15 over 5 because one of them's under the radical and one of them isn't. If they were both under the radical sign, I could have reduced it. Okay, you understand? So to reduce fractions, they both got to be outside the radical sign or both underneath the radical sign. Okay, don't mix them in. All right, is there a number that goes into 7 and 2? Can I simplify 7 over 2? No. So I'm going to rewrite it as the square root of 7 over the square root of 2. I'm not allowed to have that square root of 2 in the bottom. So I'm going to multiply the top and the bottom by the square root of 2. That's a square root of 14. And what are we going to figure? What's this going to end up being? 2. Questions? Simple, right? This is review for you guys. You guys did this in algebra 1. All right, can I add these things? These two, this 3 plus the square root of 36/5? No. But what is the square root of 36? 6. So I could rewrite it like this. You guys with me? Am I allowed to leave it like that? No. I got to do this rationalizing the denominator stuff. What's the bottom now? Just 5, right? That's all. Not too bad, is it? Again, we're going to end up with problems, some answers with radicals and stuff. So, just getting used to simplifying radicals. All right, so this is 5 minus the square root of 6 and the square root of 7. I can't reduce 6/7. And then I'm going to multiply the top and the bottom by that square root of 7. Oops, not plus, sorry. Minus. And that's the square root of 42, 6 times 7. And 7 times 7 is 49, but the square root of 49 is 7. So we're going to get rid of that radical in the denominator. Rationalize the denominator. Right, Gene? You're not going to have any questions for me, are you? This is all soaking in, right? Good. What about this one? Any ideas? Okay.
Wouldn't, did you make it 3 minus 5 over 4?
Sometimes this is a perfect square, so let's just simplify it. What is 3 minus 5? What's that reduced to?
Negative 1.
Negative 1/2. Okay, so sometimes when you get a fraction and it's got a radical in it, it's nice numbers like that. You got that perfect square in there. So you can just take square root of 25, you know it's 5, and then keep going. Finish it up, simplify it all the way. We always want our fractions in simplest form. What can I do with that 48? I like to use these two numbers. So, what happened here? What's that equal? So 2 minus, Rylan? What's that? Square root of 60. Right. You guys see that? Is that finished? Gavin? Is there any common factors to the three numbers you see up there? Yeah, 2 and 4, right? So what goes into 2 and 4? Right. So, what's 2 divided by 2? What's 4 divided by 2? What's 4 divided by 2? So you'd have to simplify that fraction down to the 1 minus 2 radical 3 over 2. Questions on simplifying radicals? All right. These are just square roots. As we go on through the year, we'll do cube roots and fourth roots the same way. We'll do the factor tree. When it's square root, we're looking for pairs. What do you think it would be if it was cube root? Triples, yeah. What if it was fourth root? 4, group of 4s. So it would be the same idea, doing your factor tree, but if it's cube root, you're looking for a group of 3 of the same number, or perfect cubes in there. Or if it's a fourth root, you're looking for groups of 4 to pull out. Okay? So this is just square root. Again, no homework tonight. What are you going to do tomorrow in class? What? Yeah. We're going to do a worksheet in class. There's no homework tonight. So you have a chance for 5 formative points tomorrow. And then you get a chance for summative bonus points on Thursday, doing some factoring problems and some of these simplifying radical problems.